So in this last video of the unit, we are going to do some mixed translations, stretches and shrinks and reflections. So we're going to do all of them possibly at the same time. So in the last video, we reviewed translations, which are shifts, left, right, up, and down. I'll quickly review stretches, shrinks, and reflections. So as a review, a vertical stretch, so vertical meaning up and down, stretching meaning to make it like taller, happen when we have a value multiplied by the parent function, and that value is larger than 1. So this says A is larger than 1. So an example of that would be like if f of x, the parent function is absolute value of x, and then we have a transformed function being 2 times the absolute value of x, then what I know is this is going to be stretched vertically 2 units. So the parent function would go through 0, 0, 1, 1, negative 1, 1. That's my parent function. My transformed function, I'm going to take this point and stretch it up 2 units, right? So it did go through 1, 1, and now it will go through the point 1, 2. This point will go through, this was negative 1, 1, so it's going to go through negative 1, 2. Okay. A vertical shrink, again, vertical meaning up and down, shrinking meaning like pushing it down, happens when the value of A is between 0 and 1, meaning A is a fraction smaller than 1. So examples of that would be like 1/2 or 2/3. Anything where the fraction is smaller than 1. And so again, if I worked with the parent function absolute value of x, this might be my parent function. Instead of it stretching up, it's actually going to stretch down. So again, this was the coordinate 1, 1. And instead, it's going to go through 1, 1/2. So it's going to be half the size. Last but not least is a vertical reflection. So vertical reflection happens when the value of A is less than 0, meaning A is a negative number. That's what we really mean when we say the value of A is less than 0. So a really quick example of that would be like g of x equals, say, negative absolute value of x. So the value of A is a negative 1, so it's going to flip vertically. So again, the parent function went through these 3 points. We would flip it. So it was up here. So now it's going to be 1 in the other direction. It was up here, so now it's going to be 1 in the other direction. That would be your transformed function. So again, that was a quick review. Rewind it if you need a little refresher. But let's go ahead and do 2 examples. I'm going to start with number 1. So it says f of x is the absolute value of x. So that is our parent function. I will graph that quickly. 0, 0. 1, 1, negative 1, 1. So this is f of x. And then the transformation is I see that it has a 2 times it. So that means it's going to be a stretch of 2. And then I'm subtracting 3 on the inside, which is a horizontal movement of right 2 units. So there are a couple ways of doing this. I like to use pencil. So I'm going to actually first stretch it 2 units. So I'm going to take this point that was 1, 1, and I'm going to make it 1, 2. So if that was all that we had, like 2 times the absolute value of x, the pencil would be my graph. However, we also need to move it right 2 units. So I'm going to take each point, I'm going to move it right 2 units. 1, 2, 1, 2, 1, 2. And so this is my transformed function. I'm going to go ahead and like erase, so to speak, my scratch work, if you will. And that is g of x. Let's do the second example. So here we see in front of it multiplied, we have 1/2, so that is a reflection, and a shrink of 0.5 or 1/2. I see here inside I'm adding 1, so that is a horizontal movement of left 1 unit. Outside I'm subtracting 2, so that's down 2 units. So quickly I'll graph my parent function, 0, 0, 1, 1, negative 1, 1. It's quadratic, so it's curved. I'm going to start by reflecting and shrinking it by 0.5. I'm going to shrink it first. So this was 1, 1. It's going to shrink by half, so now it's going to be 1, 1/2. It'd be here and here. All right? So shrinking, done. I'm now going to reflect it, so instead of it being 0.5 up, it's 0.5 down. Okay. I'm going to move each point left 1 unit, left 1 unit, left 1 unit, left 1 unit, and then down 2 units. Down 2 units. 1, 2. 1, 2. 1, 2. So this is my final graph. As a quick check, it's been reflected, meaning it's facing the other way. The origin has moved left 1 unit and down 2 units, so that's good. And these points shrunk, meaning they got smaller by half a unit.